Hi, this is the technical review for our CSE481 project. In this project, we designed a smart lock. Our smart lock system contains two parts. The first part is the system that directly talks to the lock and other hardware. The second part is the iOS app that can remotely control the lock system. Here is an overview about the hardware system. The control circuit is used to connect between the controller and the electric lock. To unlock the door, the controller first sends a 3.3 volt signal to the control circuit, and the control circuit will output a 12 volt signal to operate the electric lock. The camera is used to check who is standing in front of the door. It is also used to scan the QR code. The 2.8-inch TFT touchscreen is the interface between user and the smart lock. User can interact with the smart door, such as selecting an unlocking option or ringing the bell. The Wi-Fi adapter is used to communicate between the smart lock and the iOS management app. The Bluetooth adapter is used to check the distance between the lock and the cell phone. The door will be unlocked if a verified cell phone is tapped on the door on the lock. It also has two LEDs to indicate that if the unlocking request is approved or not.
This is a diagram showing how the system works as a whole. In this diagram, the red rectangles represent the hardware, the purple rectangles represent individual processes, and the blue rectangles represent threads inside a process, and the yellow rectangle represents the user. A typical transaction between an iOS app and the lock server is the app requests and then the server responses. To allow the server to directly talk to the app, we introduce an Apple push notification server or APN server to bridge them up. The lock server runs a REPL that reads command from standard in, while the GUI is a separate PyQt process running on the top that prints out commands to standard out, which is piped with the standard in of the REPL. When building our system, we also pay much attention to the security issue of the network communication. We use RSA-256 encrypt small packets and use hybrid encryption for video streaming. And this is our packet layout. The non-encrypted packet starts with the packet signature, followed by the packet type, sequence number, payload length, and the payload. The encrypted packet starts with the signature, followed by the length of the encrypted packet and the encrypted version of the non-encrypted packet. The packet signature is for us to validate the packet. The server will only accept requests that it's encrypted and can be correctly decrypted using the private key, which guarantees that only authorized users can control the lock. Most of the time, the server will also respond to the client with the RSA encrypted packets. The exception is video streaming packets. These packets are typically so large that they can be encrypted using RSA, so we use a hybrid encryption in this case. We use RSA encrypted packet to deliver a key. Then for the actual video frame being sent, we are actually not using RSA encrypted packet. We are trying to use XOR to encrypt the content of the packet instead. And these are the third-party libraries that we are using in a project.
Okay, thank you.